Welcome to another tutorial on MATLAB. In this particular tutorial series, we are looking into the concepts related to Simulink. And in this particular video, we will be looking into the concepts related to what are the different type of solvers that are available in Simulink. Mostly, we will be discussing on the variable type solver. What is the two types of variable type solvers that we have and in Simulink. So let's get started with the same. So if you want to design the model of any system, then in that case, you need to decide like which type of system it is. It could be either a stiff system or it could be either a non-stiff system. If you see the stiff system, then in this case, you will be having the differentiation of the output with respect to time will be some constant multiplied with some value with the output y, and it will be a variation. So this variation could be anything which will be rapidly changing over time. So basically, if you see any stiff system, in that case, your solution for the output will be changing very rapidly. So in this case, it is very hard to track it if you are using a larger sample time. Along with that, you require like a lot stability when like if you are reducing your sample time very less, then only you will be able to achieve that stability which is available within the tolerance band which we discussed in the last video. So mostly these type of systems are being developed when you are dealing with a physical system. Like here you can have a suspension system, not like mathematical modeling but a physical modeling. And when you deal with such type of models, you need to use a step system solver. We will also see like what is a step system solver and what are the varieties of step systems solver available in Simulink. So basically, when we do this, the complexity of the calculation or the solving the equation or the solving the model becomes very complex. And as it becomes complex, it takes a little more time. And also the step time is very small. In this case, so the calculation is very slow. If overall, if you see when you are dealing with very complex system, then in that case you need to use a stiff solver, and that solver will be solving it very precisely based on the type of solver, and it will be doing all the complex calculation. And mostly if you are dealing with a stiff system, it will be generated from any physical modeling type of system. So for example, you can take a RC model which is using some SimScape modeling, and there you need to use the stiff solver. So coming to what are the types of stiff solver that are available. So the first and the most popular solver that we have is ODE15S. The major advantage of having this particular solver is it solves very efficiently and with a very high accuracy, and also it can handle mixed type of models. Either it can if your system has both stiffness and it will also have non-stiffness like the other type of system, then also it can solve it. And the order that it uses is between 1 to 5, so that's why the name is ODE15S. S represents over here the stiffness, and that's why the name is ODE15S. This is one type of solver that we have. If you want to have a reduced order calculation, then in that case, for stiff solvers, we also have some few options. So if you want to have simple stiff problems, like those are not very rapidly changing, then in that case, you can use ODE23S, and ODE23S will be applicable to simpler calculations where you will be using it for simple calculations like very simple step systems, and the order of the solution will be like of second order. And in this case, you will not get much accuracy, but you will be moderately solving the problem with a moderate amount of it. Next is ODE 13T. Here you will be using the trapezoidal rule. This gives a smoother solution, so the solution will be more smooth, and also same it it is also giving a moderate amount of accuracy, and that will be used when you do not need a very high accuracy. Also, you can see the order of the particular solver is ordered. Coming to the next solver, here you will have ODE 13TB. So this uses a backward trapezoidal rule, and that with the help of this, it consumes less memory, and it also solves small step problems very efficiently, and it can give you a better solution compared to ODE 13D. The order of this particular solver is also, so these are all about the step solver which we seen. So basically, if you see, ODE 15S is the most efficient. If you do not know which one to use, you can use ODE 15S, and it will solve both type of problem also, the stiffness and the non-step system problems. But yeah, the accuracy will be very high, and here the calculation will be very complex. So you can start with this particular type of solver for step system. Now coming to the non-step system. So here the solution do not change very rapidly. You can take an example of planetary motion. So here if you want to estimate the planetary motion, then the model will be very simple, and it will be taking lot time for a larger variation, and you can deal with like a non-step solver, and you can solve it very efficiently. Along with that, climate change related models, you can also use that. So basically the intention is to use it for system which can have a larger sample time. The solution do not change very rapidly, so the cost of the calculation is also not that high. But yeah, so coming to the solutions or the solvers that are available. So if you see, ODE 45 is the most popular ODE solver that is available in the non-step system category, and ODE 23, this is also available, and it also have a faster solution approach, so it can provide you very fast solution, and it is applicable to simple systems, not like very complex, and the accuracy is also less in the ODE 23. So compared to ODE 45, ODE 23 do not perform that well, but yeah, suitable for less accurate and simple system, just to do the simulation. And next is ODE 113, suitable for the problem requires very high accuracy. So if you need very high accuracy, you need to use ODE 113 as your solver, and that will give you a better accuracy on solving your model. Next is ODE PE. So basically this type of ODE is being used to solve physics related problems, like related to quantum mechanics or quantum physics, or you can also use it for solving any physics related problems. And yeah, so these are the basic solvers that are available in the entire whole scenario. And if you see, now let's look into a model and find out how where is the variable type solvers are available, and what are the available variable type solvers in the model. So if you click on the gear icon, you will get this window, and you can see here there are two options, and there are multiple other options also. So here you can see we have the variable type solver. We have selected it as auto, so which means MATLAB or Simulink can select their own choice based on the type of model. Here you can see minimum and maximum and initial time step. So these are also being automatically being decided with the help of some inbuilt algorithm that is there inside Simulink. And if you see here, you will be able to see the relative error. You will be able to see the absolute tolerance. So these are the error tolerance that we have. Based on this, the sample time, as we discussed in the last tutorial, gets updated. So let's see like what are the different type of variable type solvers that are available in Simulink configuration window. So if you click on the drop down menu, so you will be getting different type of solvers that you are able to see here till this point. So these are the non-step solvers, and here you are having these step solvers till this point. Starting from here, you can see these are the varieties of solvers you can choose for your model, and based on the choice which you did, the variable type solvers will take care and will solve your model based on the solver type. So if you see here, so in this model, this is basically a SimScape model related to some electrical circuit. So if you see here, this is a SimScape model. And here we are using some inductor, some resistor, some capacitor. Basically, this is a series RNC circuit, and in which we are giving some input with the controlled voltage source. So through this, we are doing the simulation. And in this type of system, so basically we need a step type of solver to solve such problems, and that will give us a better solution. This is all about the solver types and what are the different step and non-step type of solvers available in MATLAB Simulink. So in case you are liking the channel, please consider subscribing. Have a great day, and thank you for being connected. In case you have any comment or query, please let us know in the comment section.